少見到佢着得咁 grand 嘅 look 啦。咁其實咧，我都買咗一樣嘢俾你嘅。
咁巧嘅，我都買咗一樣嘢俾你喎。
我哋3、2、1之後攞俾對方。
好。
3、2、1。
嗱，係睡衣啊？
係啊，係睡衣啊。因為我想你喺屋企嘅時候都可以俾到溫暖你。呢個係即係秋季，即係薄薄地，就算係而家 work from home 嘅時候都可以着到咯。咁一個家居咯，所以就俾你。同埋粉紅色，我覺得將我自己中意嘅嘢都可以送俾你。
多謝。其實咧，我喺屋企咧係真係會着呢一類型嘅睡衣嘅，即係夏天就唔會。夏天咧，我會着一啲唔要嘅出街衫啦，即係呢一種長袖秋季冷氣咁樣嘅時候咧，我係真係會着呢一類型嘅睡衣嘅。多謝。好，然後咧我就送禮物俾你。比起你嘅睡衣好似有少少諸事大，咁因為咧我嗰陣睇到男裝嘅時候，我都覺得卡其色係幾襯你嘅，點知你真係揀咗一 set 咁嘅衫啦，咁我而家就覺得呢對襪咧其實係好襯你啱啱嘅。頭先個 look 咯，即係又可以着嘅。多謝。唔客氣，雖然俾呢個睡衣你就好意思。大家記住去翻 Uniqlo 嘅網上旗艦店度買嘢啦。咁佢個網站咧界面係分類得非常之清晰嘅，而且有齊晒 Uniqlo full range 嘅商品。無論係一啲重購商品或者第一次買嘅單品都十分方便。如果你唔啱 size 咧，都可以退貨㗎。而家仲有全線門店自提服務，方便又翻工但又唔係成日喺屋企嘅人可以自己去商店嗰度拎貨。
補充翻先，有啲 collection 咧係會喺網絡旗艦店提前有得預覽嘅，可以快人一步放落購物車先，開賣嘅時候就可以第一時間買到大熱商品啦。仲有回購亦都非常之簡單，睇翻以前啲訂單咧就可以輕易回購㗎啦。
咁呢條片咧就差唔多啦，咁大家都要小心身體，翻工嘅都冇辦法，咁就盡量唔好參與聚會啦。
少啲出街玩，咁如果要 shopping 咧，Uniqlo 嘅網上旗艦店啦。
咁睇完條片要做咩
？Comment、
like、
share、
subscribe。好，我哋下條片再見，拜拜。
希望大家都中意我哋呢個 Work from Home Look 1000蚊 Challenge。如果大家有興趣，我哋今次介紹嘅配搭都可以去翻下面嘅 info box 度選購㗎，又或者自己上 Uniqlo 嘅網絡旗艦店自己配搭。拜拜。
The jungle has honed my skills to perfection. Are you faster than my blade? Here. I will ease your pain.
我玩少少嘅。由於疫情關係啦，咁我哋呢排咧都要 work from home。就算 work from home，我哋都好想拍片俾大家睇。我哋今日咧拍呢條片咧，每個人自己喺屋企做段 drama， 之後咧就再拼埋一齊俾大家。依家就準備開會㗎啦，傾下究竟我哋需要點樣拍啦 ，technical 上邊嘅注意啦，同埋啲戲咁係點樣樣啦。依家就係第2次開會情況，而家咧就等齊人去傾劇本，啲人未出現，半夜有少少咯。咁等咗一同。
Hello, Scotty. Can you hear me?
Hello, can you hear me?
Yes, it's very clear. Do you have a PPT slides to upload?
No.
Okay, great. No problem. Talk to you later.
Thank you.
Thanks for coming tonight. So we will wait for 5 more minutes for more students and supervisors to join us. Then I will go ahead to give you a brief introduction of this course and how it will be operated in this and the next two trimester. And after that, you will be giving some introduction of the projects proposed by our supervisors. And the last agenda tonight will be joining the individual session to talk to the supervisors who you want to work with in this and the next two trimesters. So this is probably what we're gonna do tonight, and I hope you find the information you need. Can you hear me?
Yes.
Oh, yeah. Thanks, TS. I just want to confirm that Keith has his microphone ready.
Hello, this is Keith. Can you hear me? Hi, Jason.
It's great to see you here. It's nice to meet you.
Yeah, it's good to see you here too.
Do you have a PPT slide to upload? So I guess you can do it now.
Okay, I'll upload it. Thank you.
Yeah, sure. Thank you very much.
Thank you.
Hello, Billy. Can you hear me?
Yes, I can hear. Thank you.
Okay, good. So do you have a PPT slide or some material you want to upload?
No, nothing. I just brief describes our topics and let the student to discuss later.
Okay, sure, no problem.
Okay.
So
Yeah, let me.
Yeah, sure. Thank you very much. So I guess we
Okay.
probably will start now by giving a brief introduction of how we're gonna run this course and what we're gonna do tonight. So tonight, as usual, we have three agendas, including the course introduction. I'm gonna take like maybe 10 to 15 minutes to give you a brief introduction, how we're gonna run the course and what you need to do, and what are the expectations we have about our students to successfully complete this course. And after that, our supervisors will give you a brief introduction on the projects. Uh, and I think each supervisor will spend maybe 5 to 10 minutes to talk about the scope and the knowledge requirements and the potential expectation at the end of the project design. And after that, we will be able to join in the individual consultation session where you can talk to the supervisors individually and ask about questions you are interested in. So the first thing I want to talk about is we have run this research method for many years since the program started. So the course structure is like this. We have like three courses, sequential courses, starting from the first course, what we call research method. Okay. So in this trimester, you will take this course and perform three tasks by the end of the trimester, including uh, finding a research project, okay? Then you're gonna work on the literature review, and after that, you're gonna do a research proposal to tell people why and how you're gonna finish the project in the next two trimester. So in this trimester, you need to choose a project, okay? Then you need to study on that project, then propose how you're gonna finish it. And after the first research method, you will move on to the design A and B. Okay, so means that in the next two trimester, you will do the theoretical development of the project you have chosen. You will do the solution. You will do the modeling, or if you are doing some hardware design, you probably have to buy some components or design some circuits. So in the third trimester, you will continue to work on your project by refining the theory, by doing hardware design. You probably will do some coding, getting some practical results, and after that, you will be finishing the final report and doing the presentation to tell people what you have done in this three trimester time. So this is the basic structure of our course, okay, which usually lasts three trimester. And starting from this trimester, you will start to learn your project and find a project that you probably want to work on. So I guess you may already find this table of supervisors and the area of interest means that most of the project will be focused on one particular area of their specialty or expertise. So if you are interested in those areas of research, and you can directly contact them by using the email address over here. And those information can be found on the project list page in Canvas. Okay, and luckily tonight we have in total 6 professors, supervisors joining us tonight, and you will have a chance to talk to them in the individual session later. Okay, so what I'm gonna show you next is my own page. So let me just quickly switch to my screen. Let me share this one. Just one moment. So you can see my page now, right? So if you navigate back to the Collaborator Ultra, you will see a few sessions in the title of Project Introduction, Electrical Engineering with the supervisor's name follow. And that means this is the individual session of this supervisor. For example, the first one is T.S. Lam. Then after the project introduction, then T.S. will join you in this session for his own consultation. If you are interested in T.S. project, you can join this session. Okay, and the supervisors will stay there for maybe 1 hour or 1.5 hours to answer questions. So if you feel interested to join any of their team, you can just click into this session and talk to them. However, this session is not available at the moment because I set the time starting from 8 p.m. So probably after the introduction, you will be able to see all these sessions available in your own page. So this is one thing that I want to share with you. Let me switch back to the files of the project introduction you saw just now. Okay. So to finish the course, we also have the 3 sessions of common courses taught by professors in other disciplines. So on September 17th, you will take the first common course session taught by myself, which is about the basic of research method and literature review. And on October 8th, another session will be delivered by Dr. Yong Tao Tan, who is from civil engineering and construction discipline. And he will be introducing laboratory research and referencing, okay? So this is mostly how you can look for your referencing need and how you can refer those references back to your own research, okay? And on October 22nd, Dr. Hamid Kayem will introduce you how to write a research proposal by using databases. And apparently, those 3 sessions are relevant to the 3 assignments you are required to finish. The first lecture, which will be taught by myself about basic research method literature review, is directly related to the second assignment and the first assignment. Okay, so in this course, I probably will introduce you how to read a journal, a technical paper, how you can identify those information in the paper that are necessary for you to understand the topic you are working on. And in the second part of the literature review, I will tell you all the elements, how you can finish a literature review, and what kind of resource and information you need to put in there. Okay, so apparently for the second common course taught by Dr. Tan, it's relevant to the research proposal as well as literature review. So you can find all the information you need for your assignments by taking those common courses. Okay. Another thing that I want to mention here is that, let me just quickly go back to the screen sharing again, because there are something you need to pay attention when you are submitting your assignments in Canvas. So let me go back to the screen sharing. Just one moment. Okay, so now you can see my screen again. And let me go back to the assignments. In this year, we run a course slightly different from last year's because this EET 2460 was only told to electrical engineering students in previous years. For example, if you ask your classmates who taken the course in May trimester, we only deliver this course to electrical engineering students. But starting from this trimester, we will start to co-code this research method among 3 disciplines, including electrical engineering, civil engineering, and mechanical engineering. Okay, so when you are submitting your assignments, okay, please follow this instruction. You are all students from electrical engineering. So when you are submitting your assignments, either it is a literature review, either it is a quiz on dissection, a paper, or a research proposal, or a presentation, you only go to the session created for electrical engineering. Is that clear? If you submit your assignment into civil engineering, it will be very difficult for us to locate, and there's a chance that your assignment will not be assessed. Is that clear? So if yes, maybe someone can type something in your chat box so that I know. So I want to make it very clear because we have 3 students from all 3 disciplines, and we want to separate the assignment submission for the convenience of both the students and the supervisors. We separate the submission portal for all 3 disciplines. So what you can see in your assignment page is we have an electrical engineering session, a civil engineering session, and a mechanical engineering session. You submit all your assignments only in the electrical engineering session instead of other 2. Okay, so make that clear. And because this is the first time that we run the course in this way, by having 3 students from 3 disciplines all together, then we want to bring this point out to avoid any future confusions. So let me go back to my introduction file again. Okay. The last thing I want to talk about is that we have a deadline of this group matchup, which is before the first lecture on September 17th. So I hope all the project matchup can be finished before the first lecture. So starting from now, you have 2 weeks to find a supervisor and to decide on a research project. Is that clear? So you have to do it promptly and quickly, because usually there are a few students who are interested in one research topic, but there's only one weekend available. Then you have to communicate with the supervisors or probably with other supervisors to decide on the project they want to work on in this and next 2 trimester. So that to make it clear, you have to do it quickly in this week and contact the list of supervisors you can see here as soon as you can. Okay, so this is something that I want to make sure you can understand. Let me make it clear. So the deadline of project matchup is on 17th September. Okay, 2 weeks away from now. Is that clear? Okay. So if there's no further question, we probably will move on to the project introduction part. And I am very honored to invite the first supervisor who are here with us is Billy Cho. So Billy, hello Billy. If you are here, you can turn on your microphone and probably say a few words about your project. Thank you very much.
Yes, I'm here. Thank you, Jason. So for this part, I will talking about some of my proposed project titles. So if you are interested, you can send an email to me or send a WhatsApp to my phone. I will leave my numbers later. And you can, I think all of you can get the files from the ones that Jason already showed you, and the uh, most of my project is focused on the smart metering in the distribution system, and you can use the lab wheel to simulate a set of the smart meters with the last cloud signals, and then we can use some fault location algorithms and locate the area of the fault. You can know it. On the other hand, you can also use the Simlinks to form a IDMT's relays model, and we will use Arduino to output some signal, so we can test the IDMT relay uh, together with the Simlink simulation models. And on the other hand, I have several projects which is proposed by the part-time students. You can see that one is the IoT lift, use some sensors to install a lift model to get the door opening time, door closing times, and as well as the waiting time for the passengers, so we can have some lift monitoring system. And the another thing is the emergency lighting, and is also some of the IoT stuff that proposed by a part-time students. And the another thing is the LiDAR, and use a model cars with a LiDARs, but you need to have some programming templates with the ROS, and as well as some middlewares to control between with the LiDAR and together with the model car. The last one is the BIM and the BMS integrations. And if if you have the knowledge between also with the building management system and building information modeling drawings, and you can have some studies to how can create a database and between the data in the building stage as well as the operation page. And so if you're interested any one of the topics or you have some new topics, you can send an email to me and we will discuss later in the individual sessions. Okay, thank you, Jason. Hello.
Okay, thank you, Billy, for the introduction.
Okay.
Just
Yeah.
a moment. I'm uploading a file, the list of projects, so student can take a look. So just one moment. Let me just find the file and upload here.
Okay.
Yeah, this is the list of projects you can see. So I guess those projects.
Yes, from 9 to 15. Yeah.
9 to 15. Yeah. So I'm gonna give students maybe 5 minutes or maybe some time to go through those titles so they can have a general idea what are those projects are about. Then we will move on to the next supervisor. Okay, is that okay for everyone?
Yes.
Yeah,
Can you see the
make it slightly
from
larger? Yeah. Starting from 9 to 15 are the research topics proposed by Billy. So you can take a quick look at those titles and think about what kind of technology or skills you might need. Then you can talk to Billy in his individual session later. Okay, so I'm gonna give you maybe 5 to 7 minutes to go through this. So I will come back at 7:20, 27 or 7:29. Okay. Okay, so let's move on to the next supervisor. Next supervisor will be Kate. Kate, are you here with us? Hello, Kate. Hello.
Yes. Yes, Jason.
Okay.
I just found
Yes, you
the
can,
micro button.
no problem. I saw you have a PPT slide, right?
Yes. Let me see how can I show my screen.
Okay.
Jason, where would I show my screen?
Let me see if I can share your PPT slide. This is cases. So this is your slide, right?
Yes, this is it.
However, I can
So-
see any word.
I can even control this the slide. Good.
Okay, great. So I'm gonna off my microphone.
Okay, I'll get started. So hello everyone. My name is Keith Lam. I am a full-time engineer, asset utilization engineer at CLP Power Hong Kong in the asset management department. So part-time, I help to lead some final year projects here at RMIT. So these are my the topic of my the final year project, which is design and simulation software for the power system equipment. So let me give some introduction. So I just give a very brief introduction of power system. So as you can see, the electricity is generated from power station, and it is transmitted through the overhead line and underground cable, and also transformed by different voltages by the transformer, and it is protected by different switch gears and down to our power outlets in our home. So all of these electricity generation, transmission, and distribution are done by different equipment. What you see here at the bottom is generators, transformers, overhead lines, underground cables, and switch gear. So so being in a utility company, we have the luxury of being able to see all of these equipment in a single company, whereby when you go to a different country, some other utilities, they are working, they only working in a power plant, or some company, they only own the transmission or distribution network. So at CLP, we're able to see all of this. So this is pretty good, interesting area for me. But when you see the power equipment, of course, the electricity, you see it just like a one line flow, right? So any of these equipment, in case it has a failure, then it would interrupt the power transmission. And of course, the equipment, you would think, oh, we just built a really nice equipment, then we don't have to worry about it failing. But however, we in the real life, we do face different kinds of challenges, such as our income, such as in Hong Kong environment, we have a scheme of control, which lower the permitted return in a utility company. Of course, we have a public expectation. The Hong Kong residents, they're having higher and higher demand of electricity. Just a a few minutes of power outages is not acceptable in our home now. And of course, in internal pressure, of course, the equipment cost is getting more and more. The maintenance cost is getting more and more. So you can see there is a conflicting cost that we have to balance. And every now and then, you will see in the newspaper that there would be a blackout, which is having some equipment failure on newspapers, some other part in the world, in other country. But in just a few years ago, this kind of incident is not too far away from us. It happened in our Black Points power station. You could see there is a bushing on a generator step-up transformer having a failure. So of course, the whole incident caused some voltage dip to the Hong Kong residents and causing a lot of elevator and escalator being stalled, and a lot of firemen being needed to rescue the people in a trapped elevator. And luckily, this incident there was no safety problem, but it was lucky because you could see this bushing was landed on a driveway, and you could imagine what happened if someone would drive along the road and have this bushing fall on the car. So that's why we needed to have a good knowledge of having a good equipment, how to build a better equipment so that it can last longer and the failure rates would become lower. And of course, in a utility, you also need to have the knowledge of being able to buy a better equipment so that you can make sure a very good quality equipment can introduce in your power system. So in this project, you'll be picking a list of equipment, and you can think of yourself as a equipment manufacturer, design engineer, and you will be needed to understand the theory of the power equipment and the calculation of these different equations, how to build up these equipments. And then you will need to use this equation to compute in Excel. So this is in Design 4A in order to have a good quality equipment. And of course, in Design 4B, you will use these calculations and compile into a program similar to the last page that I've shown you. So by the end of this project, you will have a good knowledge and in-depth knowledge of design of power plant equipment. And of course, having this valuable experience, it will hope to gain to help you for your current job or your future job. So from 1 to 8 here are the project selections, all the way from generator to transformer, switchgear, underground cable, and overhead line. So you will only choose one topic. So if you are interested, you can email me and by tomorrow. So you can pick up a topic from the list that I've shown you in the last page, and briefly describe in a paragraph about your background or your interest, why you are choosing this topic. And also, please don't forget to provide your information, your name, your student number, and your contact phone number, so that I would be able to know who you are. So this is my sharing. So I would be happy to discuss more with you later on after the whole introduction course. So thank you. So let me pass the time back to Jason.
Thank you, Case, for the
Thank you,
introduction.
Case, for the introduction. So,
Yeah, I will take it over from here. I'm gonna get back to the project list again and give you a few minutes to read through the projects proposed by Keith, and you can have a general idea what you're gonna do and what are the expectations. So as you can see here, number 25 to 32 are the projects proposed by Keith. So I'm gonna give you maybe 2 minutes to go through them, then I will come back again. Thank you.
Jason and everyone.
Yes.
I would like to, yes, I would like to supplement. Um, if you think if you choose the student choose one topic, they can also choose at least the top three of their selection. That way, just in case if someone or more than one people choose the same topic, then if you have the second choice or third choice, that would help me to select the other topics.
Yeah, sure, no problem.
yeah,
I think
sure, no
it's a good
problem. I
idea
think it's a good
because we
idea
always have
because we
conflicts
always
with
have
time.
conflicts with time.
Students are choosing a
Students are
research
choosing
topic.
a research
So
topic.
you can
Yeah.
offer the top three
the
options
top
you
three
want.
options you want.
Right. So thank you.
Thank you.
Thank you.
Okay, I guess this is Keith's introduction on the project, and I think it's time to move on to the next supervisor, and this will be Louis. I'm not
Hi,
sure whether
Jason,
Louis
everyone.
is here with us. Hi, Louis. It's great to see you here. So, do you have a PPT slide?
Yeah, I have a PowerPoint to share.
So, it is already in the system, right?
Yes, I share it now.
Okay, sure, no problem.
Um,
I can share it for you if you want. It's okay. This one, right?
can you see the PowerPoint now?
Yeah, we can see it now. It's your screen, right?
Yeah. I share the entire screen. Is it okay now?
Yeah, it's clear. You can
Okay,
start
okay.
when we are ready.
Okay, thank you, Jason. Hi everyone. My name is Louis Chan. Besides teaching RMIT design projects, I'm also one of the full-time teaching staff in Ivy, Chengyi, teaching the higher diploma programs. So if you want to find me to discuss your project, actually you can come to the campus. Um, of course, if the COVID cases is more stable, or you can also contact me by email or phone. Here is my contact information. Actually, my topics is related to wireless sensor network. As you may know, we are here talking about smart grid, Internet of Things, and also cloud computing. These all applications are grown rapidly. So you can see the research and studies regarding the IoT and devices. You see the using and the applications is growing and growing in the past years and also in the future. So wireless sensor networks actually play a key role in these applications. They are consist of, we are talking thousands, millions of wireless sensors. So the point is how we can group all those sensors healthily and to maintain a stable and reliable services for all the applications. This is our challenge. One of the key factors that we need to focus, as you know, because the wireless sensors are mainly battery, powered by battery, because there is no hard wire to connect without stable power supply. So one of the challenge is how to save the energy in order to maintain or balance the loading of the whole sensor network. So there are some studies or research from others. The source is from Onward. You can see the satisfaction level among all the criteria. You can see the right-hand side. The battery lifetime is always the least satisfaction among all those factors. So this is what we have the challenge, and we can have a focus of it. And also, you can see on the right-hand side for the battery lifetime, many users think that battery is a very important issue because, as you know, no battery, then all the sensors die, not only the sensors die, no data. So maintaining a healthy battery lifetime is a very important issue, but you can see the satisfaction level is still very low. So that means there is a very large gap here. We can have an improvement here. So wireless sensor have some characteristics. As I said, we are talking about millions to billions sensors, and they are wireless, which may be fixed, or sometimes it is moving, mobile, and do not have the consistent power supply, and with limited processing power, memory, or storage. These are the characteristics and are the constraints of using these wireless sensor network applications. So one of our challenge or improvement that we can think about is how to reduce the energy consumption or power consumption of the sensors, or how to balance the energy consumption among all these sensors so that they can share the loading, they can have maintain a more healthier environment for all those applications. Actually, when you have a research of the papers in Google Scholar or IEEE Explorer, you can easily find there are thousands of papers talking about these areas. in the past or also in the future. So there are many, many different methods. So one of this method, maybe I introduce one of this, and others let you to discover, or you may have a new idea. So one of this is, instead of, you can see there are some circles here. That means the white one is the sensor, individual sensor. And the black one is the CH, means cluster head. And you can see on the right-hand side, there's a BS, that means base station, to receive the data or signal from all those sensors. So one of the technique that we can use is, instead of, because everyone may know the energy consumption sometimes is related to the distance of transmissions. The longer the distance, the higher the energy consumption. So if every individual sensor sends the data with a very long distance, the base station, then it may cause a lot of energy, consume huge energy. And every node, individual node, will die very fast, quickly. So instead of sending the data individually, some researchers propose that, why don't we have a group? We call it cluster. So within the group, we have a cluster head, and all the members will send the data to the cluster head first, and then the cluster head will collect all the data and then send to the base station. So this can shorten the distance, and also the cluster head will also send to another cluster head with some routing algorithms, with some techniques. Actually, in this diagram, it can have several topics. For example, we can think about how large the cluster size is. How many sensor nodes is suitable within one cluster? What is the criteria for setting that size? So this may be one topic. Another one is how to select a cluster head. Okay, based on what criteria? So I will not talk about this at this moment. I will let you to think about it. And is it the same cluster size within the whole diagram, whole network is suitable? Or we can divide it to some level. Okay, so it depends on the location or whatever parameter. We have a suitable cluster size for different levels. And some researchers also think about it. Okay, so is it the same cluster head will work for forever? Of course not. We need to change. So when to change, how to change, what are the criteria to change? These are also another topic. Okay, routing algorithm is also another topic. So even with this single diagram, we can have several topics that we can talk about it. Okay, for my projects, we will mainly use the network simulator to simulate the environment, the scenario. Of course, if you're interested in these topics, somehow you need to have some programming skills. You're not scared of writing programs. Okay, and you have some basic networking knowledge will be better. Okay, so if you're interested in these topics, I think you can discuss with me in another individual session, so we can talk it in more details. Yep, that's all for my presentation. Jason, thank you. Thank you, everyone.
Thank you, Louis, for the introduction. So I will quickly open the project titles proposed by Louis, and you can take a quick look. So as you can see, the projects starting from number 3 to number 38 are the projects proposed by Louis, and I'm gonna give you like 2 minutes to quickly go through them. Okay, so let's move on to the next supervisor. Will be Scotty. So Scotty, are you here with us?
Hello, can you hear me?
Hi, Scotty. It's very clear, so you may start your session when you are ready.
So yeah, maybe you just keep the project list here. I guess that's good for me.
Mhm.
So I wish the student can see the screen shared by Jason. So basically, you can see this is my project. I will say my project is basically divided into two main categories. The first category is about power electronics. For power electronics, my project is more on the control of a power converter. So I believe you already learned about what is a buck converter, boost converter. But I believe most of the time when you learn about that is also in an open loop configuration, which means that you basically apply a fixed duty cycle, and then for whatever input voltage, you calculate the output voltage. You really have no a mechanism of regulating the output voltage when the supply is changing or the load current is changing. So for my power electronics project, I would like students to investigate or to focus on one particular power converter, and then to try to find or investigate on different control methodology and find the most suitable one for their selected power converter. And once they select the suitable control methodology, the remaining job is to implement the controller and then to see how is the performance. So in the old day, I find the students are very interesting. In the old days, students really love to get their hand dirty to build a converter. But it sounds like nowadays students really want to stay away from hardware. So I'm open for students if you really want to build a hardware for power electronic. I would say that that's more than welcome because if you really work in power electronics, you will know that no matter your simulation result is perfect, but once you build it, you will see a lot of crazy stuff. So for students really would like to work on power electronics, they can either pay to do simulation-based project, or they can pay to do a project that need to build a hardware. So that's I will open this for students to pick. For details about those power electronics stuff, say which type of converter I can do, what kind of control you can do, I guess I will leave it in the following session. Okay, but basically I will tell you what we're trying to do in power electronics. The second category is on machine learning. Okay, so my project is kind of extended to the two extremes. Okay, one is really hardware, one is really software. Machine learning is I would say, a very hot and sensitive topic in these days. A lot of people is talking about machine learning, and we also experience a lot of benefit or advantage of machine learning application like face recognition. We can use face recognition to easily identify who is in a video or picture. When you type a message, basically right now Google or Facebook or whatever the giant company, they can basically know what is the next word you would like to type, right? Those are all benefited from the machine learning, or to a bigger scope, we call the AI. So for machine learning project, in the old day, I give students hard topic in the sense that I really would like students to work on machine learning in a hardcore sense, that they really need to build their code. They really need to understand the operation of the machine learning instead of just bringing in the machine learning model that is not developed by them. But I find that as these years, the machine learning advancement is rapid. So students are getting harder and harder to step into the field for the given time that we have for the project. So I guess from this year, I will try to change the direction on more application oriented. So basically, for all those machine learning projects, I would like to student with, when you want to work on that project, you need to have an idea how you would apply machine learning to solve some real world problem, or some, it can be a toy problem, but it need to be I mean, I will not, it's not a good word, but difficult in the sense that you still surmount the minimum the difficulty in terms of a 5-year project. So basically, I would like to put right now the machine learning as an application project. And you will see there are actually two categories of kind of subcategories for machine learning project. One is called machine learning application. Another one is called teeny machine learning application. So the basic difference is that the machine learning application is still when the code are executed, or we call deployed for application, it's really on a relatively powerful machine. Okay. Those I would say is a more classical application. For example, hey, I want to build a system to recognize the people in a photo and then identify who are they, or I would like to do language translation from Chinese to English, or vice versa. Those I would say that is more on a PC level, or at least a powerful notebook level project. The other two one are actually new for this run. That's the first time I offer, which is called the Teeny machine learning application. Actually, when you search Teeny ML, we call Teeny ML, is another hot topic now that people in the industry really would like to work on and talk about. That is actually related to something that IoT, or people now combine AI with IoT, called AIoT or edge computing, a lot of jargon term. But the whole idea is that we would like to put machine learning into some platform their computational power is not as good as a mainframe or a server. Basically, the best case will be a microcontroller. And how can we optimize the code, or reduce the accuracy, reduce the computational requirement, but without sacrificing the accuracy, and then do some simple stuff. Say, for example, when you nowadays wear the smartwatch, you find that they're very smart in the sense that they know when you climb up a hill or step up the ladder, when you are actually jogging around at the seafront, when you're running, when you're actually jumping. Actually, behind they are basically using IMU, which is we call the Inertial Measurement Unit, and collect a lot of data. They basically ask a lot of people to, hey, just keep jumping for a day, and then get the data to identify what kind of data pattern that is jumping. And then finally, they stream down the model and put it inside a microcontroller or smartwatch. And that's how they recognize all those compressed movement and identify what exactly you're doing. And there are lots of applications. I don't want to spend time here. We can talk more in the later session. But I would like to give the difference or what are the difference between T&E machine learning and machine learning. Basically, for T&E machine learning, the deployment or the technical term we call it inferencing is basically on a computational power limited platform like microcontroller, Arduino, or can be better like Raspberry Pi. Okay, so these are the project I will offer, and if you're interested, just find me to talk in more details. Okay, thanks for the time.
Okay, thank you, Scotty, for the introduction. So
Thank you.
I guess it's very clear about the scope for the projects proposed by Scotty. Those are about machine learning, tiny machine learning, and power electronics. And if you're willing to learn more about the scope of those projects, please feel free to join the individual session hosted by Scotty later. I think the sessions are now already available, but we still have like a few supervisors who would like to introduce their projects. So let's move on to the next one, should be TS. Because I know that Stephen has already introduced his project in other occasions, so maybe we can just move on to TS.
Okay, no
Yes, are you
problem.
here with us? Yeah, sure.
Yeah.
You can start whenever you're ready.
So Jason, would you please help me to open my PowerPoint?
No problem.
I can't
Just one
do
moment.
that. I can do that, but for the uploaded file. Let this run, okay. So that's control as well, right? Okay, student, good evening. I'm TS, Dr. Lam, and my project area, my interested area actually is in computer vision and its application. So in terms of application level, it can apply to some intelligent systems and transport systems or healthcare, okay? Frankly speaking, I don't have any fixed project title, so you can propose your own relating to my interested area, okay? So tonight I would like to share with you some selected projects that I thought I categorized them as a good project, okay, in their implementation. So that will let you know more about what I did in the past, okay? Okay, so this is the selected project. Okay, the first one actually is a study on the effect of the template size in fingerprint recognition. Okay, I like the algorithm developed by my students is simple algorithm. So it is just using simple pattern recognition methods to recognize the fingerprint. Okay, so this is the result. Okay, so when you look at that two chart, you find that actually the template size which should be optimized in some certain dimension, such that in order to have a better accuracy and a reasonable processing time, okay, but not sacrificing the accuracy rate, of course. Okay. So this is a very interesting topics done by my students. Okay. In that year, my student purchased a fingerprint devices from Taobao. Okay. And he wrote his own programs to achieve the objective of this project. Okay. The programming tools that I would like to use is LabVIEW, okay, which is we got the campus license and anyway, so you can use it anyway. And I believe that you have learned a little bit LabVIEW in your high diploma program already. Oh. Okay, so the next project is make use of a Kinect sensor, okay, to detect, to perform the fall detection, okay. So to analyze the X, Y, Z position of the head, so you can observe the focus, okay, on the right hand side of the PowerPoint, okay. So you can see that when the human falling, that will create a falling edge, of course. Okay, the slope of the falling edge will determine whether it is lying down slowly when he sleep or falling, because the slope are different. Having said that, on top of that, actually on top of that, you can observe some hitches, some changes when or on the falling slope, okay, and that may be caused by, say, the hitting the head. What I mean, the head hitting on some objects, okay, that will create some problem, okay. In that sense, alert or alarm messages should be sent to, say, to their families members in order to reduce the risk of this falling. Okay, so this is one good application, and detecting the risk actually is the first. I didn't see this kind of application before when I did this project. Okay, and this is also a very interesting project for me. Okay, that is make use of some simple statistic to extract the length, okay, successfully. Okay, the major challenges of image processing is due to the light, environment light, as you see, because that the actual pixel color affected by the environment severely. Okay, so the student at that years make use of some average intensity, okay, to determine the threshold value to extract the length, traffic length. Okay, so the successful way is pretty well. Okay, so this is a very good example. Okay, so for this one, the student implement several different methods to extract vehicle. The major challenge in this application is actually the background changes due to the sunlight movement. Okay, to extract the vehicle, it is very simple, because when we extract the current images, subtract the current images from the background, original background without any vehicle, then the vehicle can be extracted very easily. Okay, unfortunately, the background is changing because of the sunlight. Okay, so the challenge is how to reduce that effect. And the student applied a median filter, which is averaging fill frame, okay, in order to reduce the effect of the changes, okay, and successfully perform vehicle extraction in this environment, okay? And you can see that the successful rate is pretty high, it's over 90%, okay? So this is a very interesting project with real application. Okay, should be the last one. I thought it's very interesting, which is sign recognition, okay? To simplify recognizing the hand sign, the student proposed to use color graph, okay? Make use of different color, extracting different colors from the images mean extracting the fingers, okay? And consider the finger position, the number of fingers, and then the hand sign can be identified, okay? So this is also a good and interesting projects in the past. Okay, that's all the project I would like to share with you. And apart from that, in this year, I would like to propose one more project that I have to do, I would like to do, which is relating smart meter. Okay, the idea is I would like to make use of those smart socket with power measurement feature, okay? And I would like to integrate those many smart socket, okay, in your home, okay? And to monitor the status of your appliances, including the health and the usage, okay? I don't want to touch on the hardware, so the hardware should be bought from the market, and you have to write your own program to integrate those smart socket together, okay, and develop the application, okay? So that's all what I would like to share with you. Thank you.
Okay, thank you, TS. So I guess what I'm gonna do is to show you the previous research project titles supervised by TS, and you can think about what new ideas you can come up by looking at those old research projects here. So I'm gonna give you like maybe 2 or 3 minutes to go through them. Then we will move on to the next supervisor, which is myself. Okay, I will come back in a few minutes. We're gonna take maybe 10 minutes to quickly go through the scope of the project that I would like to supervise in the next 3 trimesters. But actually, the project title can be discussed if you show your interest of doing your research in those areas. Then we can start to talk about what a specific topic you would like to work on. But in generally, I proposed 3 areas of research that related to power electronics, which is my areas of research interests. But one thing I would like to state in the beginning of the introduction is that power electronics circuits or systems are not something that we see vividly or in visual, as they are usually the components or a system that is hidden inside of a machine, of a device that we use every day. For example, you saw the operation of your air conditioner, but you hardly see the movement of the motor inside. You know your phone is charging, but you hardly see how the circuits are working inside. So I'd like to see that computers actually are the brain of the modern industry and technology, whereas I compare power electronics as the heart of the modern industry. And in this area, we actually try to play around with the powers, with the waveforms, with the current and the voltage from both AC to DC, from low level to high level. Those are the general scope of power electronics. Of course, we sometimes take advantage of the modern control technology, computing technology, modern theory, but still, what I focus on is how we can make our power consumption, power delivery, power generation more high efficient, more safe, and more environmental friendly. So toward those end, I proposed three areas of research that you might be interested in. The first one is what we call multi-level converter. As you know, currently we have a lot of renewable generation, like windmills, like solar panels. Those generators or renewable generations are actually attached to the high voltage level. See, usually the device that we use are actually attaching to the 110 or 220 volt AC bus. But in fact, when those generators or those windmills or PV generators are attaching to the grid, they are usually going up to 10 kV or sometimes 110 kV. So facing something that of high level of voltage, and we have to find a way to do so. In traditional power converter, what we're doing is that we'd like to have everything attaching to the grid. See, this is the AC grid. We have ABC three phases. And this is device we have attaching to the grid, okay? So power electronics is doing one thing, that we try to make sure that the current flow from the device to the source as sinusoidal as possible. So for three-phase system, you're going to see a three-phase sinusoidal current waveform flowing from the device side to the grid side, or the other way around. But in general, what we're looking for is a pure sinusoidal waveform, or something that is as close as a sinusoidal waveform as possible. So therefore, we have this filtering technology to be implemented. And one way to do so is actually we try to make the action of those switches in a way that the average size of the pulse is equal to the size of the small section of the sinusoidal waveform to be almost the same. And in that way, you generate a sequence of pulses with the changing duty cycle, okay? If you learn a little bit about the Fourier transformation theory, then you know you can decompose those pulses into the spectrum of signals. And by using the filter, we can save those signals that we want to use, we want to implement, we're expecting, then blocking those that we don't actually need, okay? So those high frequency pulses contains those low frequency signal that we need and those high frequency signal that I don't want. And by implementing those filtering technology, we can actually have a pure sinusoidal waveform or something that is as close to the sinusoidal waveform as possible. Okay, this is the basic theory, how we do the modulation and the filtering. But in order to implement this technology in a high voltage level, what we need to do is to have a few sub-modules of those single phase or three-phase systems. Say you have this one single module with two switches. This is a single module of the high multi-level converter. If you put those small module or sub-module together in a series, then you can create a voltage level that is much higher. So a simple understanding is that if you have a simple module over here, you create a voltage level which is like the first step in this waveform. You have a small step up, okay, due to the implementation of one single sub-module, okay? You have one step waveform. Then if you have a second sub-module implemented, you can have another step up waveform. Then by doing so for a few times, you can create a sinusoidal waveform as close to the ideal or real sinusoidal waveform as possible, okay? So this is the whole concept of multi-level converter. First of all, we want to do it by using some low voltage components to create a high voltage. And the second objective is we would like to create a waveform as close to a sinusoidal waveform as possible. Okay, so under this topic, we have many things to do. For example, you can design the circuits by using either it is a 5-level or it's a 13-level kind of converter, or you can do the modeling, you can do the control, and you can also do the integration part of the multi-level converter with the power grid. So, I mean, the specific topic are always open for you to discover. The second project has been done for quite a few times in the previous semesters. And the full title is actually called Maximum Energy Efficiency Transfer of Wireless Power Transfer, which means we'd like to capture as much energy as possible when we are doing the wireless power transfer. This is why we give a title as Maximum Energy Efficiency Transfer. So I guess you are very familiar with the wireless power transfer because you probably have already gotten one for a toothbrush or your phone charger. But those technology are what we call old technology. It is purely based on the older theory, which we call Corliss transformer, and the adopted international standard is called QI. Okay, that means the alignment between the primary and secondary coil has to be perfect. When you charge your phone with the wireless charging pad, you have to put your phone exactly on top of the pad. Okay, so the energy can be transferred from the primary to the secondary. Okay, you don't have any coil inside, and mostly what you can see is a very simple coil, and on the other side will be some converting system to convert the power source from an AC type to a DC type, and that's all. Okay, there's no closed loop control, and what you do is based on the simple principle of a transformer, but in a much higher frequency. This is what we call Corliss transformer, or the wireless transfer based on QI standard. But in the future, we would like to do some closed loop control. The idea is that if we can change the nature of the load in certain way, maybe in what way A or way B, okay? If we can change the load of the system in one way or the other, then probably there's a chance for us to improve the efficiency of the system to the most, okay? So why, and how can we do that? And the whole theory is actually starting from the modeling of the wireless power transfer by looking at the coupling effect between the primary and secondary coil. And by doing those modeling, eventually we find if we modulate the input voltage, means that if the input side of the voltage is changing from a high level to a low level, you vary the input voltage of the system, of the entire wireless charging system, you are able to increase the efficiency over here, starting from very low, below 10, all the way up to a maximum point. Theoretically, you can reach about 70% of the efficiency. Then and the efficiency starts to drop again if you keep decreasing the voltage. So the modeling tells us that if we can find a way to change the input voltage of the system, or in other words, the nature of the load, we are able to find a maximum efficiency point for the entire wireless charging system. Then the second issue is how can we do this in a closed loop manner, which has not been implemented industrially, okay? So the second scope of the research or the project that I would like to supervise is on finding a way to achieve the closed loop tracking of the maximum efficiency of a wireless power transfer. Okay, so this is the second project. The third project, this is a redundance, so you don't have to pay attention to it. The third project is what we call model predictive control of power transfer, of power converter. This part has been done for 2 trimesters as well. So generally what we do is actually very straightforward. If you look at the 3-phase power converter, it's mostly about how you switch those switch components. You have 1, 2, 3, 4, 5, 6. You have 6 switches. And by making use of different combinations of the switch, you can get different outcomes at the output terminal of the converter. It's a very simple logic. You have a controller for a PS4. By pressing different button, you got different outcome. Okay, so in power electronics, we have 6 switches. By switching in different pattern, we have different outcome at the output terminal of your converter. So the second question is, if we can derive a model which is sufficient to describe the behavior of the converter by considering the different switching pattern of your 6 switches, then we can control the converter to the way that we want, okay, for either composition of the grid or driving the motor or lightening LED light, okay, in any way that you want. So the idea of model predictive control is actually we have to establish a model of this 3-phase power converter. Then we try to implement some control concept, either facing the grid or some actuators such as motors, such as EV drivers, such as chargers, so that the control action can be taken in a predictive manner. Okay, so this is the general idea of how we operate this 3-phase power converter in practice. So this is the project that I would like to share with you. And by any chance you are interested in them, you can send me an email or send me a message in Canvas. So to finish this session, I would like to share with you another document that you might be interested to look at. So just one moment. I guess this is common for all supervisors here, which means when you are contacting a supervisor, we would like to have some personal information. It doesn't have to be long. It can mean a very short or very concise answer to this following 4 questions. But we are looking forward to know something about you before we're taking you in for the projects. One thing is we need your personal information, such as your name, your RMIT student ID. I know you have a VTC student ID, but this is not the usual student ID we use for the courses delivered by RMIT. So I'm expecting the RMIT student ID here to keep in record. Then your email address. Then probably you can give me a phone number if you like to. And after that, you can answer a little bit about what your background is about, what the skills you have, and what is your understanding about the project, what you know or what you expect yourself to know. Then you have the expectation for this project. What would you like to do, and what knowledge you are ready to acquire. So it doesn't have to be long. It just has to be in a very concise and short answer to address the 4 points when you're contacting the supervisor, so that we know something about you and we know you probably are interested in those projects. Then we can take you in. The second reminder is, I hope you can choose the project based on your interest and look at what strengthens you are. You know that projects are different a lot in aspect of hardware requirement, coding skills requirement, theory requirement. If you're a person who naturally hate coding, then you have to find something require less skill in coding aspect. If you are someone who hates doing hardware, then you have to find something which is more software oriented. However, if you are someone who hates everything, okay, I think there's no such project. You just have to settle down on one that you feel comfortable to do. Okay, this is the second reminder or recommendation. The third recommendation and reminder is that you have to do your project selection as soon as you can. First thing is, there will be quite a few students are interested in one project. Then you have to do it quickly and promptly so that you can get or secure the project you want to do. The second reason is you only have limited time to finish your project. In this trimester, you only have 8 weeks to do so. If you cannot finalize your project in the first 2, then you are left yourself with very limited time to finish your assignments, to do your project. Okay, so try to do it as soon as you can after today. Then I hope you can finish your project matchup by the end of next week, Friday. Okay, so this is everything that I want to share with you. So let's move on to the next session. I guess the supervisors will be with you in their individual session, and you are free to join any of them and to talk to supervisors face to face. So thank you very much for joining tonight, and I will see you in my session later. So See you. So I guess supervisors can leave the session now and attend your own session. Those sessions are now available in Collaborate Artro, and the student can leave this session as well and join the individual session. You can see the name of the supervisor on the end of the session name. Okay, the name is already there, so you can leave now and attend the session you are interested. But